All right. So there's rules for what transformations do. And by transformation, I mean, if you remember, we talked about a parent function, and it's like the simplest version. So the parent function for absolute value of x looks like this, right? Just absolute value of x. Don't forget, f of x means the same thing as y. You should have learned that. You should have be familiar. You should have seen f of x before in various places. And it just means function of x, in other words, y, okay? So if your parent function is absolute value of x, then your transformations are anything that alters the parent function, okay? So if I added 2 right here, I added 2 right here, I added 2 right here, you know, all of those are transformations. We have, let's see, 8 different transformations that we're gonna learn, but they pretty much come in pairs. So it's almost kind of like 4 and then the opposite of those 4. So hopefully it won't be too bad. So I'm going to introduce each transformation and then show you on the graph what it looks like. So the first one is if f of x is transformed to be, ooh, you know what I can do? No, it's going to be too much trouble. I'm just going to do it this way. F of x is transformed to be f of x plus d. So that's a general rule, and examples might be absolute value of x transformed to be absolute value of x plus 3. Okay, so essentially this is your transformed function, right? You just added a plus 3 on the end. And we call that adding outside the function. The function is f of x, and in this case, it means the absolute value bars here. And we're adding outside of the bars, so that's outside the function. So what that does is shifts up d units. Whatever d is, that's how much the shift up is. So for our example, absolute value of x plus 3, it should shift up 3 units. So I'm going to switch to Desmos here. If I had my original absolute value of x, and then I do absolute value of x plus 3, as you can see, it was at 0, 1, 2, 3. It's the exact same function otherwise, but everything is shifted up 3 units, 1, 2, 3. Any questions there? 1, 2, 3, etc. All right, if there are no questions. So that is an example of a shift up. You know what, I like having black one as the starter. I'm gonna do that. Okay, shift up. Okay, so that's a shift up. Let me see. New share, back to whiteboard. All right, and likewise, you'll find something very similar for my number 2, and yet the opposite. Why do I keep on doing parentheses first? Minus d. Okay, who wants to take a wild guess? If plus d shifts it up, what do you think minus d does? You can unmute or put it in the chat. If plus d shifts up, what do you think minus d does? Common sense, y'all.
It makes them go down.
Nice. Good guess. So if plus d shifts up, minus d shifts down. Okay. So we could say example x minus 2. All right. So let's see what that looks like. if I get rid of this and instead do absolute of x minus 2, boom, you can see we have our original, and then it was at 0, now it's at -2 because it shifted down 2 units. Pretty simple, right? Hopefully y'all are okay with that. Let me know if you have any questions. All right, so that's a shift down. Okay. Oops. All right. Number 3. F of x is f of x plus c. Now notice the main difference between number 3 and number 1 is that in number 3, the addition is inside the function, and number 1, the addition is outside the function. Okay, so example, this could be absolute value of x plus 3 this way, and you see the difference inside the function versus outside the function, inside the absolute value bars versus outside the absolute value bars, makes a big difference. And what this is going to do is shifts left C units. Okay. All right, so let's give that a try. Oops, hang on. Where's my Desmos? There it is. So that was plus 3 inside. And as you can see, it stayed the same way vertically speaking, like this was at 0 on the y-axis, this is at 0 on the y-axis, but it shifted 3 units to the left. So 1, if I zoom in close, it'll count. There we go. 1, 2, 3. 3 units to the left. Any questions there? Okay. Now that one's a little bit counterintuitive because, you know, when we shifted up, the numbers went up. We shifted down, when we added, the numbers went up. When we subtracted, the numbers went down. And this one's kind of weird because we're adding, but the numbers are going down. But so that's one that I think a lot of people mix up because you think, okay, plus it's going to go plus 3, but instead it goes, you know, back 3. So that was something you got to keep in mind. Okay. Back to the whiteboard. Okay, another wild guess. If plus c shifts it to the left, what do you think x minus c does?
It shifts it to the right.
Good job. Awesome. So we can do x minus 2 there. All right. And let's see what we've got. Okay. So x minus 2. And yes, as you can see, 1, 2. It shifted 2 units to the right. Okay. So again, counterintuitive, you'd think the subtraction would make it go back, but instead it makes it go forward. And that's just something you got to remember, that the horizontal shift, remember horizontal means left and right, left to right. Horizontal shift is the opposite of what you might think, right? Plus makes it go into the negatives, minus makes it go into the positives. Okay. All right, those are the easiest ones. Well, actually, the others are kind of, a couple of the others are kind of easy too. We have 2 that are a little bit more confusing. Okay. So this one is a times f of x. So that means multiplication outside the function, okay? So an example might be, no, I'm going to do the examples later. Now, the reason that this one can be a little confusing is that there's actually two possibilities for this. And it depends on A. If A is greater than 1, we call this vertical stretch. And if A is less than 1, it is vertical compression. If A is equal to 1, then 1 times something is itself, so it doesn't change at all. So you're never going to see A equal to 1, because then it just wouldn't be there. Just like we don't say 1x, we just say x. Okay. So vertical stretch or vertical compression. So example here might be 2 times absolute value of x. And an example here might be 0.5 times absolute value of x. Okay. So I'll show you in the graph what we mean by vertical stretch and vertical compression. Okay. So if I say 2 absolute value of x, notice it still has the same origin, like it still has the same point here at the origin, but the red function is narrower. And that's because if you think of vertical stretching something, so vertical is up and down, remember. Imagine if you took the ends of this function and pulled them up and down. I'm doing hand motions, but you can't see me because my screen is shared. If you pull them up and down, let me see. I'll stop the share for a second. Okay, look at me. If you have your ends and you pull them vertically, you stretch them vertically, then you're going to see it become narrower, right? If you have something like this and you stretch it vertically, then it becomes narrower, okay? And likewise, we're about to see vertical compression, and I'll just do this now. If you take them and you stretch them horizontally, no, vertical compression, I'm sorry. If you take vertical compression and push it down like this, that makes something spread out, you know? If you have 2 pieces of bread and something between them and you clap them down and it squishes out, that's going to be vertical compression. So let me share again. Okay. So that was 2 absolute value of x. That's vertical stretch. You're pulling them apart from top and bottom, and that makes it get narrower. Now, if you do vertical compression, and you have 0.5 times absolute value of x, then you can see the blue one is wider than the original. And that's like if you're squishing down, like I said, then it gets wider and shorter. Okay. So that's vertical compression or vertical stretch. Okay. So now we've got multiplication inside the function. This is our other one similar to number 5. Oops. And it has similar deal. If b is greater than 1, it is horizontal compression. Yeah, didn't see that one coming, did you? And if b is less than 1, horizontal stretch. So kind of the opposite of the vertical. So a greater than 1 is vertical stretch, b greater than 1 is horizontal compression. A less than 1 is vertical compression, b less than 1 is horizontal stretch. Okay, so example would be absolute value of 2x. Okay, I'll do 1.5x. Just make it different. And this one would be 0.3x. Okay, 3/10. Either way, point is they are greater than 1 and less than 1. So basically, what you'll see is that vertical stretch and horizontal compression are kind of the same thing, and vertical compression and horizontal stretch are kind of the same thing. You'll never be asked to look at a graph and say whether it's vertical stretch or horizontal compression, because that would be impossible without being given the function. So let's try these. So one was 1.5x. So as you can see, that's also narrower, just like our vertical stretch. And essentially, it's a horizontal compression. Imagine if you're coming from the left and right and pushing the V together, that's going to make it narrower, right? And then 0.3x, that's a lot wider, because horizontal stretch means you're taking those two ends of the V and pulling them apart, and that makes it a lot wider. Let me stop the share real quick to show you. So horizontal compression, you're pushing in like that. Imagine there's a V between my hands. There's a V and I push it in like that, it's going to get narrower. Whereas if I grab both the endpoints and pull it apart, that's horizontal stretch, it gets wider. So that is that. Okay, so horizontal compression and horizontal stretch, kind of opposite of vertical compression and vertical stretch. Okay. All right, we got two more that are fairly simple. Number 7, f of x equals. So if you look, what I did was put a negative sign there. And that gives you reflection across x-axis. So, example, negative absolute value of x. And you remember how when we studied absolute value functions, we said that, you know, the negative made it go flip upside down, and that's basically what we were doing. So boom, reflection across the x-axis. So you know this is the x-axis right here. It reflects across, so it just flips over it. And that's what the negative out front does. That's a negative outside the function. Now with absolute value, it'll be kind of hard to see the opposite. I'll tell you why. Let me see. Let me scoop this up. Okay. We'll just make do. Okay. F of x transformed into f of negative x. All right, so this one should be a reflection across the y-axis because of the negative inside the function. So that would be, I'll put the example here since I'm running out of space at the bottom, x negative. Now, you're not going to see this really on the graph, and I'll show you why in this case. if we do absolute value of negative x, oops. It makes the exact same thing. See how it turned red, black, turn it on, it's red, but it's the same graph. That's because we're flipping it across the y-axis, but the thing is, it's symmetrical across the y-axis, right? If you flip it across the y-axis, it stays the same. So a better way to show you that would be if I have, x minus 2 here, and then I put negative x minus 2, now you can see that that is a flip across the y-axis. So see this little purple part here, flipped across to the black part here. This purple part flipped across to the black part here. This purple part flipped apart to the black part here. So that negative with the x makes it reflect across the y-axis. Okay, and that will be apparent in other functions we do, like x cubed. If you have negative x cubed, that you can see flips across the y-axis. That you can see it, but in absolute value, it doesn't show it with just the parent function. Okay, so this is the 8 transformations, and you do a couple different kinds of problems with this. You either are given transformations and asked to draw write the function down, or you write the function down and then you're asked to describe the transformations. Hang on just a second. I want to save this picture. Okay. Okay. So I'm going to clear this. And we are going to do a few problems. So basically, if I tell you absolute value of x is transformed to be 2 times absolute value of x plus 3. You're going to look at your handy dandy list of transformations that you have. It'll be in the, I'm going to put it with the assignment. I'm going to put it inside the Google form. I'm going to put it in the resources. You'll have this list everywhere. You're going to look at your transformations and say, hang on. Transformations. And you're going to say, okay, I see that I have addition inside the function. And so you go back to your list and you say, addition inside the function, where do I see that? Ah, I see. This is shifting left. And then you go back to your whiteboard and say, shift left 3 units. Then you say, okay, here's a 2 outside of the function. What does that do? And you go to your picture and you say, let's see, that's multiplication outside the function. Ah, here's multiplication outside the function. And then you say, 2, is 2 greater than 1 or less than 1? So 2 is greater than 1. So you go here and you say, that's a vertical stretch. And you write here, vertical stretch. And you're done. You have listed the transformations that have occurred. Every number that is present that wasn't in the parent function, which is every number, counts as a transformation. So however many numbers there are, that's how many transformations there are, with the exception of if there's a negative sign, that also counts as a transformation. So at most, the number of numbers plus the number of negative signs is the number of transformations that you need to account for. Any questions about this so far? Okay. So again, what if we had transform to be 0.4 x minus, I'm going to do this, negative point x minus 1. All right. So I always think it's helpful to first start out naming how many transformations we have. So I'm going to say 1 for the negative, 1 for the 4, and 1 for the minus 1. So we should have 3. So what does the negative do? Is it inside or outside the function? Let's actually get an answer from someone on that. Is this negative inside or outside the function? Okay, let's do it this way. That negative sign, let me remind you what our function is. Negative 0.4 times x minus 1. Okay, right now we are looking at the negative sign. So we have 8 functions here, 8 transformations here that are numbered, 1, 2, 3, 4, 5, 6, 7, 8. Which one, you can just say 1 through 8, which one is that negative sign? Transformation number 1, transformation number 2, transformation number 7, and transformation number 8, 3, 4, 5, 6, etc. Just say, put a number in the chat if you want. What transformation is that negative sign? Which number? Come on, y'all. It's a negative sign. So that narrows it down to like 2 options. Think about whether it's inside or outside the function. One, 2, 3, 4, 5, 6, 7, or 8. Anyone? You guys, you're making this video long. One, 2, 3, 4, 5, 6, 7, 8. What's the negative sign out front of the function? I'm literally on the screen right now showing you the transformations. So
Is it the one on the left?
can you say a number? 1, 2, 3, 4, 5,
4.
6, 7. Huh? 4? No, 4 would be subtraction inside the functions. That would be inside the absolute value bars. This negative sign is outside the function. And it's not really, I mean, we have subtraction in it, but the negative sign that my black arrow is pointing at is a negative sign, not subtraction. So which, thank you for trying. That's better than everybody else can say. But anyone else have a guess? Negative sign outside the function. Where do you see that in our 1, 2, 3, 4, 5, 6, 7, 8 list? Hmm. You guys. Do people really not know, or are they just not responding? It's so hard to tell. Okay, you win. I'll say something. Number 7. Look at that example. Look at that. It's a negative sign in front of a function. Our example is a negative sign in front of a function. I wish that that had been clear. I don't know what I can do to make that more clear. It's a negative sign, and I told you it's a negative sign outside the function. This one shows a negative sign outside the function. So I don't know what to tell you guys about that. Okay. Let's see if anyone can tell me about the 0.4. Remember, that's like 4/10. So it's being multiplied outside the function. So is that 1, 2, 3, 4, 5, 6, 7, or 8? Multiplication outside the function. Which one does that look like? Whoever's coughing something up, your mute isn't on. Which one is that? 1, 2, 3, 4, 5, 6, 7, 8. Multiplication outside the function. Y'all are killing me. I don't understand. Can someone tell me what they're confused about? I mean, I went over all of this. I said addition outside the function, subtraction outside the function, addition inside the function, subtraction inside the function, multiplication outside the function, multiplication inside the function, negative outside the function, negative inside the function. So now that I just did that, I just told you again the answer. It's multiplication outside the function. Which one was I pointing at? 1, 2, 3, 4, 5, 6, 7, 8. Y'all can see, right? You can see what I'm looking at. I'm looking at my picture of all of the functions listed and labeled as 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's come back to that one and do an even easier one. What about the -1? So that's subtraction, and it's outside the absolute value bar, so that's outside the function. So subtraction outside the function. Which transformation is that? 1, 2, 3, 4, 5, 6, 7, 8. Okay, Brian Aguero said 2. Great. Yes. So he saw this is subtraction outside the. Okay. So that is what the -1 does. So at this point, we've got 7. That's the reflection that comes from the negative sign. And we've got number 2. That's a shift down that comes from the -1. And now we've got multiplication outside the function. So 1, 2, 3, 4, 5, 6, 7, 8. Which one shows multiplication outside the function? Okay. It's number 5. Look at this. That is multiplication outside the function. This is the function. This is the multiplication outside of it. Okay? So once you see that, you have to say, is it greater than 1 or less than 1? Someone tell me, is 4/10 greater than 1 or less than 1? Greater or less than 1? Brian says less. Thank you. So, awesome. Ingrid says less. That means we're talking vertical compression. All right. That was a pain. Okay. So the negative was a reflection over the x-axis. The 0.4 was a vertical compression. And the -1 is a shift down 1 unit. Okay. Any questions there? Apparently no one was able to identify a reflection or a vertical compression. So I don't know what to do. I have the list in front of you, and I'm not sure how much more clear it can be than having the list in front of you. Please, study that. And I don't know what else to tell you. Okay, I guess we got to do another one since people aren't getting it. Maybe that more practice. All right. No. Okay. Let's say f of x equals x is transformed to be f of x, whoops, absolute value is transformed to be -5 times absolute value of x minus 2. So what transformations occurred? All right, so we have, again, 3. Negative sign, the 5, and the minus 2. Remember, inside the function versus outside the function means inside the absolute value bars, like the -2 is, or outside the absolute value bars, which the negative and the 5 are. Okay. So -5 minus 2. Okay. So let's try this again. What does the negative do? 1, 2, 3, 4, 5, 6, 7, 8. It's a negative outside the function. Which transformation is that?
5.
Okay, one person said 5, one person said 2. So we're talking about the negative here, not the 5. Okay, another person said 5. Okay, you guys might be looking at the 5. But remember, the negative and the 5 are two different transformations. So what does just the negative sign do? Forget the 5 here. What does just the negative sign do? It's actually not 2 or 5. So we're just looking at the negative sign right now. Brian, I see your number 4. That is the correct answer for a different question. You guys are naming all the transformations that are here except for the one I'm asking for. Okay. So I'm looking for the negative sign. So which transformations show a negative sign in them? Not subtraction, negative sign. We had this exact same one on the last problem. Boy, I was also going to do some problems with the other way where you're given the transformations and have to write the function, but I'm not going to have time now. Okay, 6. 6 is multiplication inside the function. So there's no negative sign with number 6. Can you guys see 7 and 8? Okay, I'm kind of wondering if people can see if like there's a mess up with the screen sharing. This is too low down. Can you guys see number 7? So number 7 clearly has a negative sign out front. You can see it in the example and in the rule. Can you guys see number 7? Someone tell me yes or no. Hello, is anyone there? Can you guys see number 7 on the screen share or not?
Yeah.
Okay. Okay, so you guys can see it. So really, when you see a negative sign, there's nothing in front of it, so that's not a minus, it's just a negative, then you should be looking at your reflections. So a negative in front of the absolute value is this reflection across x-axis. Now, a bunch of people were saying number 5, and I think that they were looking at, it's kind of confusing because it's also the number 5. But this 5 right here, why is it blue all of a sudden? This 5 right here, I think that's what people were thinking when they were saying number 5, because that is, again, multiplication outside the function. This time, though, is it stretch or compression? Someone tell me if this is vertical stretch or vertical compression. It depends on whether a is greater than 1 or less than 1. Is 5 greater than 1 or less than 1, y'all? Thank you. Okay, it's greater than 1, so that means it is vertical stretch. Okay, and then -2 inside the function, so that's the one that Brian earlier, I think it was Brian, yeah, said 4. So that's -2 inside the function. So we can look, we see there's a -2 here, but it's not inside the function because it's outside this parentheses, right? So that's not right. And then down here, that's where I see a minus inside parentheses. So that is, in fact, my example, I just now noticed my example is the same, -2. So you definitely should know that that is number 4, shifts right. Okay. So we've got another reflection over the x-axis. We've got vertical stretch because it was bigger than 1, 5 is bigger than 1, and we've got shift right 2 units, number 4. So those are 3 problems. Any questions about any of those? It seems like this is something we're still kind of struggling with. I don't know if it's a struggle in people really not knowing or a struggle in people responding, not wanting to respond, or a struggle in people walking away from their computer once they've set the Zoom up and not listening. I don't know. But I'm going to be putting up a Google form assignment shortly, and I really hope that people can do it. I will include in several different places the list of all the transformations so that you can use it as a reference. So please make sure you look carefully at all of them as you're looking for what transformations you need to use. So it's 10:30, so I would like to stop. Okay, yeah, that's been, so